so after you've created your first aggregation and you have photographically documented it, and you do this to the point where you can reconstruct this in Rhino, which is why I'm having you document it from all of the cardinal points, because you're going to have to redo this in Rhino with your snap to grid turned on. Okay? And I know for a fact that all of you now know how to use Rhino to make a cube. I know you know how to copy cubes, and I know you know how to move them around in space. So this should require absolutely zero input from your 121 faculty. This is all really, really basic stuff. Okay? Do you guys agree or disagree? So you guys can reconstruct this thing without needing to have your student, your digital instructor tell you step by step how to do it. Okay. All right. So after you've created this kind of vertical kind of crossing aggregation, I want you to create a horizontal crossing, okay, where the pieces are kind of butting into each other like that. And then I want you to create a linear one where the elements are sort of offset from each other and create just a straight long line. Okay? Remember that I'm asking you to express exact simple repetition in all of these schemes. All right? So you're going to do, that one was vertical like this, right? Next, you're going to do one that is linear like that. Okay? So it's expressing a much longer line by taking two of these and bringing them together. And then you're going to express one where they're connected like that. For doing these, you can turn them on their side like this temporarily so that you don't end up with the coplanar surfaces, right? And remember, the floor can be coplanar. You can also, if you want to, you can use little spacer blocks, right? So like you can use pieces of foam core or something to kind of lift something up off the ground. So for example, if I have 4 of these and I place them along there, I automatically get this differentiation in height, right? But if I take one of these and I put it next to that, I don't get that differentiation, do I? And so in a case like that, that's where you can take something that will allow you to space it up. So for example, you could use some of those pieces of foam core. So you could use, a couple pieces of foam core, maybe 3 pieces of foam core at a minimum, right, to kind of raise it up. And you cut the pieces so that they're smaller and not visible underneath this thing. Does that make sense? So that's going to be part of your homework. It's going to be to document and print this out and do it in Rhino. Okay? Any questions?
The print is from Rhino or the pictures?
From the pictures. Actually, you know what? No, let's just do it. Rhino's easier, right? Rather than printing all those pictures, you guys can just kind of print stuff out of Rhino. Yeah, do it out of Rhino. Okay? But I do want the pictures. So the pictures are, I guess what I'm trying to teach you is that a lot of times when you try to make a Rhino model, it takes a long time, right, to just make one. After that, it might pick up in speed. But I can very quickly play with blocks like this, right, and I can come up with a lot of schemes just by moving stuff around. Whereas if I try to get you guys to do this in the computer, it sometimes takes a very, very long time. Okay? All right, any questions? All right, so keep working at that.
You're supposed to have 9 pictures from Rhino, right? The 9 angles?
Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. All right, keep going. I'm going to have your project handout in just a moment.